Let's take a look at Regents Review number 20. Question number 1 asks you to find an equivalent expression. So we're going to need to distribute these coefficients. And remember, this one has a -1. So we're going to get 6g minus 8 minus 8g minus 3. When we combine these like terms, we get -2g, and we combine those like terms, we get -11. So -2g minus 11. Let's take a look at the second question. A car leaves Albany, New York, and travels west towards Buffalo. The equation d equals 280 minus 59t can be used to represent the distance d from Buffalo after t hours. In this equation, the 59 represents the what? So we notice here that we have a linear equation. And when you have a linear equation, the coefficient of the variable is always the rate of change, right? How the car is changing, right? How the car is changing its location. And you do that by driving the car a certain speed. So it looks like, since d is distance and t is time, that this would be y and this would be x, right? So the rate of change is the change in y over the change in x. And distance is measured in miles, and t is measured in time. So we have miles per hour. So that's how we know it is the speed of the car, the miles per hour. Let's take a look at the third question. The third question gives us the formula of Celsius in terms of Fahrenheit to convert between these 2 degrees. The question over here is if Faith calculated the Celsius with an input of 68 degrees. So the input is the letter F, so we would take the letter F and we would remove it and replace it with a 68. Simply pick up your calculator and compute. When typing on your calculator, you should type it exactly how it appears on your paper. Press enter, and you'll get your final answer. Now be careful when selecting. So the input was 68 degrees, but the output of Celsius would be 20. So it's 20 degrees Celsius. Let's take a look at the last question. What type of relationship exists between the number of pages printed on a printer and the amount of ink used by that printer? All right, so the relationship would be a comparison of the number of pages printed, so number of pages, and the ink used. So if I print 1 paper, I've used about this much ink. Print 2 papers, I use a little bit more ink. If I print 3 pages, I'm going to use up even more ink. If I print 4 pages, I'm going to use up even more ink. So it looks like we've got a positive correlation. And the more pages I print, the more ink I use. So it is causal. The more pages I print, the more ink I use. Question number 9 has a system of inequalities, and I can see already that this one here is not in slope-intercept form, but this one is. So that one would be ready to graph if I wanted to check it on my calculator. The first one would require a little bit of manipulation, and it would be to subtract x from both sides. And now I have my 2 inequality statements. You'll notice that this one has a less than or equal to sign, and this one just has a greater than sign. Right? You notice that? So that means that one of them should be dotted, and one of them should be solid. I already know that those 2 are wrong. So I could certainly graph this on my graphing calculator, and I'll show you that in a minute. But I know that this one is the dotted line, and so that should have a y-intercept at +2, and it should have a slope or rate of change of down 1, right 1. So +2, down 1, right 1, down 1, right 1. Yep, so that seems to be working. Now let's check the shading. Is it greater than? So that shading would be this way. So this one doesn't have that. So therefore, I know that number 2 has to be the correct answer, but we could use our calculator to be sure. So with an older app, once it's turned on, and you put your cursor on the equal sign. So you have to have your cursor on the equal sign in order to see these buttons, right? So we're going to choose greater than, which is 1, 2, 3, the fourth one over. So I'm going to press alpha and the 1, 2, 3, fourth button over. And there it is. And the second sentence had less than or equal to, so that is the third button, alpha zoom. And then we'll type our actual sentences here. You can take a look at the graph, and you'll see dotted line, shaded up, solid line, shaded down. And it will look like the choice that we chose. Let's take a look at question number 6 here. At which point does this function reach its maximum value? So we haven't gotten to our unit on quadratics, but we do sort of understand some basics. So why don't we just graph this quadratic in our TI-84? Negative x squared plus 6x minus 5. We'll go to our y equals button. We'll type negative x squared. Then we'll type plus 6x. And then we'll type minus 5. We'll take a look at the graph here. And we can see that it's curving here. This is the vertex, also known as the maximum point, since it's the highest point along the curve. So we could certainly look in the table, but it would be a lot faster to just calculate that maximum. We're going to use this calc button right here above the trace key. So you'll notice it's in blue, so I'm going to type second, trace. I'm going to choose number 4, maximum. And now all I have to do is get this little blinking cursor by moving the left and right arrows to be on the left bound side of the maximum. Press enter. Move my cursor to the right bound side. Press enter. You'll see these two imaginary lines appear, and that zone should contain your maximum point. Go ahead and press enter, and there it is. So the maximum point is 4. It happens when x is 3. So depending on where your cursor is, you may get this approximate value, but that is a 3. But the maximum value is 4, right? 3, 4. So we'll select our choice and keep moving. Question number 7 asks us to determine the smallest integer that makes negative 3x plus 7 minus 5x less than 15 true. So I'm going to combine like terms here. Get negative 8x plus 7. Then I'm going to subtract 7 on both sides. Now don't forget, when you divide by a negative with inequalities, the inequality symbol is going to reverse. So I now have a greater than sign and a negative 1. Now the question states, determine the smallest integer that makes it true. So x has to be a number that's greater than negative 1. So when you're on the number line, and you're at negative 1, the next integer that's greater than you is 0. So the smallest integer is 0. So it's important now that I take this solution box away and give it to this answer. Question number 8 talks about a residual plot. The residual plot is the distance from predicted data to the actual data, and what we're looking for is a nice scattered area. So this is a good fit. And it says explain using evidence from graph A and B. Which graph indicates that the model for the data is a good fit? That's it. Question number 9 reviews the transformation of a function. This one happens to be a linear function, right? Negative 2x plus b. If b is increased by 4 units, then that's the constant at the end. Constant at the end is a translation up or down. And since it's being increased by 4 units, that means that it is moving up 4 units. Question number 10 describes Rowan has $50 in his savings jar and he's putting in $5 every week. So every single week it increases by $5. So Rowan has 50, and then he adds 5 per week. That's a linear function. Jonah has $10 in his own jar, so Jonah has an initial value of 10, and he's putting in 15 per week. Each of them plots his progress on a graph with time on the horizontal axis, that's the W, and the amount in the jar on the vertical axis, that's the Y. Which statement about their graphs is true? So Rowan, if graphed, would start at 50 and then go up about 5 each week. That's Rowan. And Jonah would start at 10, but he's going up 15 each week. Right? You see the difference there? So Rowan's graph has a steeper slope? No. His rate of change is lower, so that's not true. Rowan's graph always lies above Jonah's? Probably not. Jonah's graph has a steeper slope than Rowan's. That's definitely true. And the reason why I know that the graph for Rowan won't always be greater and Jonah won't always be lower is because Jonah is growing at a faster rate. So let's circle that here and move on to question 11. To watch a varsity basketball game, spectators must buy a ticket at the door. The cost of an adult ticket is $3. The cost of a student ticket is $1.50. If the number of adults tickets sold is represented by A and student tickets by S, which expression represents the amount of money collected at the door? Well, we know that it's $3 for each adult. So it's $3 times A. We are also additionally selling $1.50 for student tickets. So $3 for each adult, plus we will add in the money for the students. And they're not the same prices, so we can't add them together like this. So the answer would be number 4. Let's take a look at the last question. This one is a bit of a challenge, but we started working on this week, so let's take a look. Last week, a candle store received $355.60 for selling 20 candles. Small candles sell for $10.98. Large candles sell for $27.98. How many large candles did the store sell? I'm going to take some notes here. So there are sentences that require money and sentences that require the number of items sold. And so that's important for you to recognize. So the money is that there was $355.60. $355.60. The amount is that there were 20 candles sold. Now we know we have large and small candles, so we can call them L and S. And the basics is that if you add all the large candles we sell to all the small candles we sell, then that would be 20 in total. This top sentence, though, talks about money. So I have to add up all the money for the large candles and all the money for the small candles, but I have to know how much money they each are. So this sentence needs the money for the coefficients. So it's $10.98 for the large, and, oh, sorry, I messed that up. $10.98 is for the small, and $27.98 is for the large. And now I have a system that I can solve. So I can use graphing, I can use elimination, or I can use substitution. I think I'm going to use substitution here because I can isolate a letter down here rather quickly. So I'm going to isolate the letter S because I want to know how many large candles I sold. So I'm going to subtract L from both sides and get 20 minus L is what a small candle is equal to. So now for this sentence, 27.98 L plus 10.98 small, but instead of a small, I put 20 minus L. And all of that is equal to $355.60. I'm squishing it in over here. Okay, I know it's pretty small, but let's focus here on distributing. So 27.98 for the large, plus, used a calculator here, all right, now I'm going to combine like terms. So 27.98 minus 10.98. 27 minus 10 is 17. Plus 219.60 equals 355.60. I'm going to subtract 219.60 from both sides. Use my calculator, and I got 136. And when I divided that by 17, I got 8. So the final answer is 8 large candles.